With that being said, we are now ready to start the first method session, which is the DBS library screening. Why is screening necessary in today's world? Because many times people cause accidents or show curious behavior or strange behavior, and it is not sure if they are under the influence of drugs. Also in the US, very common is to perform workplace drug testing in order to ensure that your workers or co-workers are not under the influence of any drugs. The advantages of screening in dry blood spots are various compared to other procedures. In whole blood, we have a minimally invasive sampling process. The sampling can be performed on site without the need of a healthcare professional. Furthermore, blood is the matrix of choice to tell if somebody is under the influence at the moment. This cannot necessarily be done by using urine or hair samples. Additional advantages are that DBS are stable at room temperatures, do not need a biohazard label, have reduced storage and shipment cost, and the process itself of the analysis can be performed fully automated. We published 2 papers which focus on drug screening, one depicted on the left in the Journal of Applied Bioanalysis, and one focusing more on forensic approaches of screening in the Journal of Analytical Toxicology. Nowadays, what you can do in order to do forensic screening based on triple quadrupole system is that you can use pre-arranged spectral library databases, for example, the one from Shimadzu, where you have various MRM transitions and spectral library background information for a lot of compounds. For example, for the one from Shimadzu, there are 2 separation conditions available, one with a C18 ODS kinetex column, or one with a biphenyl resecraptor biphenyl column. The ODS method package itself comes with information for up to 250 compounds, and the biphenyl method contains up to 1281 compounds, which can be screened within one run. Some of these compounds are overlapping between the 2 methods. Nowadays, also SciEx starts to offer a similar product to screen for 664 compounds in under 10 minutes on a QTOF system. What you can do is with this Shimadzu system or library is that you can use a compound list creation tool which comes within this package. There you can decide if you want to do MRM screening or MRM screening with spectral library screening. Based on that, you can insert the name of the target drugs you want to investigate into this compound list creation tool. Afterwards, once you have inserted all the compounds of interest, you hit create, and then it automatically gives you a text file. This text file can then be imported within your mass spectrometer system, where you have already a prefixed LC parameters, which afterwards can be adjusted upon your needs. So by using your custom target list, inserting that into the LC system, you can then start optimizing the LC parameters and also the MS compound windows dependent on the number of analytes and the behavior of the analytes onto the column until you have your customized fast screening method for your target compounds. The chromatogram, which is recorded by using this spectrum mode, is depicted here for a ecognin methyl ester. You have MRM transitions for the quantification, which are screened, and afterwards, once you have a signal, the MS-MS spectrum with 3 different collision energies is recorded. The use of these three spectra with three different collision energies is that you can afterwards, with the software, merge this spectra, which helps then to identify different compounds with a library which is in the background of this package. This is depicted here in the middle. You can then apply this like butterfly spectrum, which gives you a similarity index to the library hit, which is saved in the background. If you use different concentrations in order to set up your screening, you can not only screen nowadays, but you can also get a very good estimate of the concentration which is present within your sample. Furthermore, you have, dependent on how you set up your method, qualifier, quantifier, and internal standard, which confirm that you are really investigating the right compound. Furthermore, there is already a retention time pre-saved within the method package. The library hit which you get is depicted here as an example. It's based on similarity index, which increases confidence. Overall, depending on how you set your method, you can then have compound identification by, as already mentioned, retention time, multiple MRM transitions. This can be several, this can be 5 or 8, depending on the compound. You have the merged spectra, you have the library search similarity index, and you can have the internal standard. With that being said, I would like to show you now a method example which we did within our laboratory in Muttenz, just to show how such a method performs. This was done on a Shimadzu 8050 coupled to our autosampler based on the ODSS separation method with a total runtime of 6 minutes with the standard recommended solvents from Shimadzu. And for the extraction of the DBS, we used 20 microliter of a 50-50 methanol water solution with some formic acid and ammonium formate within. What we recorded was a 6-point calibration from 25 to 250 nanograms per milliliter in blank blood. And afterwards, we recorded only one QC at 25 nanograms per milliliter and one high QC at 125 nanograms per milliliter for the various target compounds like codeine, dihydrocodeine, amphetamine, methamphetamine, MDMA, cocaine, benzylacetate, ecogene methyl ester, methadone, methadone metabolite, alprazolam, and diazepam with the respective internal standard. As you can see, the linearity which you can obtain is really high. We almost for every compound got R of at least 0.99. Furthermore, the concentrations estimate which you get out of this screening method are also quite accurate. With this, I would already like to summarize this part and then go on to phosphatidylethanol. What you can do with our instrument is the fully automated and validated DBS screening based on your approach. You can have a forensic library which allows you to get additional confirmation, and the degree of confidence which you want to have in your screening method can be adjusted upon your need. Furthermore, barcode on the filter paper card allows you to integrate the sample processing into your laboratory information system, so you could fully automate all the processes, starting from the receivement of the sample.